Okay, very good afternoon, my dear students. Today we can discuss the properties of entropy. Already we stated some of the properties of entropy. So we defined that entropy is the average information content due to which is generated by the discrete memoryless source. It is defined as a ratio of total information content individual divided by the total number of messages. That is nothing but the average information content. So already we define the expression for entropy as minus summation j is equal to 1 to m p suffix j log p suffix j base 2, and here the units are bits per message or bits per symbol or bits per element, and here pj is the probability of jth element and capital M represents the total number of messages. In the last class we discussed the properties of entropy, and out of that the first property is if a data stream consists of single message with a maximum probability P1 is equal to 1, then the entropy is 0. Because if a data stream consists of only one message, then here M value will be 1. So it will be minus only one message exists. So that's why P1 log P1 base 2. So minus P1 log P1 base 2. Or else you can also write this as P1 log 1 by P1. So because we represented P1 inside the logarithm, you can put it as negative sign. So it will be minus 1 log 1 base 2. So log 1 is 0. So that's why if a data stream consists of only one message with maximum probability P1 equal to 1, then the entropy is 0. And the second property is if a data stream consists of multiple messages, but out of them if only one message have the maximum probability equal to 1, so from the definition of entropy, already you know that if a data stream consists of multiple messages, for example, capital M number of messages are there, but if only one message has maximum probability and if all the other message probabilities are 0, then the entropy is 0. So that is minus summation j is equal to 1 to m p suffix j log p suffix j base 2. So only one message has maximum probability equal to 1. So for example, P1 be 1 and all other P2 to PM values are 0. So that's why 1 log 1 base 2 minus 0 log 0 base 2 minus 0 log 0 base 2 up to so on m number of messages. So log 1 is 0 and 0 multiplied by any value gives you 0. So that's why total entropy will be maintained at 0. So if a data stream consists of multiple messages, but only if one message has maximum probability equal to 1 and other message probabilities are 0, then the entropy is 0. So third property is entropy of a particular event is always greater than 0. Therefore, minimum entropy of event is equal to 0. So h of e is greater than or equal to 0. So always h of e value is greater than or equal to 0. It equal to 0 in the first two properties we studied. So always h of e value is greater than 0. Let us consider, so already we told this fourth property. Here what we did, we considered two messages m1 m2 and the respective probabilities be p1 and p2. Then our entropy will be p1 log 1 by p1 plus p2 log 1 by p2. So log 1 by p1 is minus log p1. So that's why minus p1 log p1 base 2 minus p2 log p2 base 2. But what is the sum of all message probabilities? Here two messages are there. So the sum of two message probabilities should be equal to 1. For example, if you assume P1 as P and P2 as P2 will be 1 minus P because P1 plus P2 is 1. So please substitute P1 and P2 values as P and 1 minus P respectively in the entropy expression. We obtain this as H is equal to P log 1 by P base 2 plus 1 minus P log 1 by 1 minus P base 2, or else you will get negative side, so minus of P log P base 2 plus 1 minus P log 1 minus P base 2. And fifth property is like that. Already I told you that this is the continuation of a fourth property. So maximum entropy of the event with two equally likely messages is 1. So what is the maximum entropy of the event? So maximum entropy of the event with two equally likely messages is 1. And that occurs at P is equal to 1 by 2. So for equally likely messages, their message probabilities are same. Okay, so what is so P1 will be equal to P2 is equal to P, but P1 plus P2 is equal to 1, because sum of probabilities of an event is 1. It implies that P plus P is 1 because the two messages are equally likely. Okay, for equally likely messages, P1 is equal to P2 is equal to P. So that's why upon replacing P plus P is 1. For equally likely messages, their message probabilities are same. That is P1 is equal to P2 is equal to P. Okay, here 2P will be 1. So P will be equal to 1 by 2 or 0.5. So entropy is equal to minus of 0.5 log 0.5 base 2 plus 0.5 log 0.5 base 2 minus of log 0.5 base 2. So you know that log A base 2 will be log A by log 2. So it will be equal to 1. Already we calculated that log 0.5 by log 2 is minus 1. So minus of minus 1 will be plus 1. So in the last class we discussed that maximum entropy of the event for two equally likely messages, you can see that it is for example in this graph you can see that H max versus P. So here maximum entropy occurs when P is equal to 1 by 2. Okay, here maximum entropy is 1. So whenever P is greater than 1 by 2 or less than 1 by 2, our entropy value will be less than 1. Okay. Now this property we did not study in the last class. Okay, listen carefully. So this if you observe the sixth property, it is the extension of the fifth property. What is the fifth property? Maximum entropy of two equally likely messages. Maximum entropy of two equally likely messages occurs at P is equal to 1 by 2. That is the second, fifth property. But if you observe the sixth property carefully, maximum entropy of m equally likely messages. Okay, so how many messages are there? Capital M number of messages are there. And these are represented as M1, M2, M3 up to so on, MM. So this many number of messages are there with their respective probabilities as P1, P2 up to so on, PM. And this occurs at P is equal to 1 by M. This occurs at P is equal to 1 by M. Okay, and that maximum entropy is how much? Log M base 2. It is log M base 2. But actually, what is the maximum entropy? What is the maximum entropy for two equally likely messages? It is 1. And that occurs at P is equal to 1 by 2. But here the maximum entropy of M equally likely messages. M equally likely messages is log M base 2. And the units of entropy will be bits per message, because here we are considering M equally likely messages. So bits per message is the unit for Hmax. Okay. So please observe carefully. So maximum entropy of m equally likely messages m1, m2 up to so on mm with probabilities p1, p2 up to so on pm at p is equal to 1 by m is log m base 2 bits per message. Okay, so for equally likely messages, first you should know that what is the condition. For equally likely messages, P1, all the probabilities of the individual messages are equal. That is P1 is equal to P2 is equal to P3. Up to so on, all are equal and it is equal to 1 by m. And it is equal to 1 by m. Sum of all message probabilities of an event is 1. So sum of all the message probabilities of an event is 1. That is P1 is equal to P2 is equal to up to so on Pm. Okay. So all these message probabilities are so maximum entropy will be log m base 2 that occurs at P is equal to 1. So because all the messages are equally likely, their probabilities are equal. So P1, P2, P3, Pm, all the values are equal and it is equal to 1 by m. Why it is equal to 1 by m? We know that sum of all the message probabilities of an event is 1. So how many messages are there? M messages. So sum of all the message probabilities, that is P1, P2 up to so on Pm is 1. So using these two expressions, that is upon replacing P1 as some P, P2 as some P and P3 as some P and P1 also some P, because all these values, let us assume, consider all these as some P. So M into P will be 1 because M number of times you are adding. Okay, so P will be 1 by M. So that's why the probability of all the individual messages is 1 by m. But entropy for m number of messages is defined as what is the general expression for entropy of m number of messages? It is a summation series that range from 1 to m. So summation j is equal to 1 to m. Pj log 1 by pj base 2 అని చెప్పాం. Okay, so it will be P1 log 1 by P1 plus P2 log 1 by P2 plus up to so on Pm log 1 by Pm. Here we are going to calculate the entropy. So maximum entropy. Now please replace all the probability values as 1 by m. All the probability values as 1 by m. So P1 replace it as 1 by m. Similarly P2 replace it as 1 by m. Up to so on Pm also you replace it as 1 by m, because in the sixth property statement itself we have considered all the messages as equally likely. So please replace all the probability values as same, and that same is value is 1 by m, because sum of all message probabilities of an event is 1. So please replace P1, P2, P3 up to so on Pm as 1 by m. So upon replacing all the values as 1 by m, our entropy will be P1 log 1 by P1. So P1 is 1 by m. So log 1 by Pm, 1 by 1 by m వస్తుంది ఇక్కడ మీకు 1 by 1 by m. So it will be m plus P2. P2 is 1 by m log 1 by 1 by m, that is m, plus up to so on plus 1 by m log 1 by 1 by m, that is capital M. So it will be 1 by m of log m plus up to so on. Just I took 1 by m as common from this. I took 1 by m as common so that you will get a series of log m base 2. But this log m base 2, but this log m base 2 is added like how many times? M times you are adding. So that's why 1 by m into log m base 2. Log m base 2. So that's why H max will be here, m and m gets cancelled. M and m gets cancelled. So you will get it as log m base 2. So what is the maximum entropy for m equally likely messages? It is log m base 2. But what is the maximum entropy for two equally likely messages? You can keep m value as 2 here. So what is the maximum entropy? What is the maximum entropy for two equally likely messages? Just replace m as 2. Then you will get it as log 2 base 2. Log 2 base 2. That is nothing but log 2 by log 2. So it will be 1. So maximum entropy of m equally likely messages occur at p is equal to 1 by m. And its entropy is how much? Log m base 2. Its entropy is log m base 2. So please observe this graph shown here. So in this graph you can observe that it is the characteristic between H max. It is a characteristic between H max, that is the maximum entropy, and the probability, and the maximum entropy on the y-axis versus probability on the x-axis, So probability is how much? 1 by m. At p is equal to 1 by m, and p is equal to 1 by m, you will get a maximum entropy. How much? Log m base 2. So please remember this equation. Okay. So with this, almost all the 6 properties of entropy have completed. L9 ఉందమ్మా, L9. L9 ఉన్నారమ్మా, L9. Can you please explain the 6th property just now we studied?
Maximum entropy of m equal of event with two equally likely messages is 1. For equally likely messages, their message probabilities are same.
మా మహాదేవి, your voice is like too low. ఒకసారి చెక్ చేసుకోండి.
Actually, I'm suffering from cold, madam.
Oh, okay. So then sorry. Okay, I will call some other student. No problem. K0. J4 Punyavati. K5. K5. Okay, how many students are following the class? Please raise your hand. How many of you are following the class? Please raise your hand so that I can see in the chat box. How many of you are following the class? Please raise your hand. Laterality 28. N4. N4.
మేడం
My వినిపిస్తుందా? బట్ ఏంటి మరి మీ క్లాస్మేట్స్ నో వన్ ఈస్ రెస్పాండింగ్. Okay, can you tell me the property, sixth property of entropy?
Yes.
Tell me what you
Maximum
understood.
maximum entropy of m equally likely messages with probabilities p1, p2 and so on pm occurs at p equals to 1 by m.
Okay.
And maximum entropy at that probability p equals to 1 by m is log m base 2 bits per message.
Explain
We know
the
sum
proof
of all.
what you understood.
Okay. We know sum of all probabilities of an event is 1. So p1 plus p2 plus and so on pm is 1. Because of equal probabilities, p1 equals to p2 equals to p3 equals to and so on pm equals to 1 by m. But we know that entropy equals to summation j equals to 1 to m pj log of 1 by pj. Here j is ranging from 1 to m. So h equals to p1 log 1 by p1 plus p2 log 1 by p2 plus and so on pm log 1 by pm.
Yes.
But probability values are probabilities p1 p2 are equals to 1 by m. So substitute 1 by m in p1 p2 pm values, then h max we get is log m base 2 bits per message.
So if you, okay, Ma, thank you. So if you observe you can observe the same from the graph. So maximum entropy occurs. Maximum entropy is how much? Log m base 2, and that occurs at p is equal to 1 by m. So if you want to get the maximum probability of two equally likely messages, that is the fifth property, you take the same expression and replace m as 2. So you will get log 2 base 2. So that is how much? It is 1. Similarly, if you want to get the maximum entropy for three equally likely messages, it will be log 3 base 2. Log 3 base 2. And that occurs at 1 by 3. That occurs at P is equal to 1 by 3. Similarly, H max for 4 equally likely messages is log 4 base 2. Log 4 base 2. And that occurs at P is equal to 1 by 4. So similarly, this is extended for m number of messages. So maximum entropy is log m base 2 and that occurs at P is equal to 1 by m. Let us do this problem. So here let us calculate the entropy for three different cases, under three different cases for a data stream consisting of two messages. For a data stream consisting of two messages. So m is 2. M is 2. So here the data stream consists of only two messages. So what are the two messages? P1 is equal to 0.01 and P2 is equal to 0.99. This is the first condition. And second condition is P1 is 0.4 and P2 is 0.6. What is the third condition? Can any one of you tell me what is this third condition called as? P1 is equal to P2. What is this condition?
Equally likely messages.
Yes, that is equally likely condition. Here both the probabilities are equal and it is equal to 0.5. That's why we can say that it is equally likely condition where the two probabilities are equal. And even if you can take the sum of the two probabilities, that is P1 and P2, in all the three cases, if you observe, the sum of the two probabilities is 1 because this event consists of only two messages. So sum of the two probability, like two message probabilities should be equal to 1. So P1 plus P2 should be equal to 1. So if you observe first case 0.1 plus 0.99, that is 1. And second case kuda 0.4 plus 0.6, that is 1. And even in the third case, it is 0.5 plus 0.5, that will be 1. So what is the this third condition is equally likely condition where the two probabilities are equal and it is equal to 0.5. Now what is your question? Your question is to calculate the entropy for the three cases and see which case will get highest entropy. Okay, what is the definition for entropy? H is equal to minus summation j is equal to 1 to m p suffix j log p suffix j base 2 bits per message. So you can, because there are two messages, capital M will be 2. So P1 log 1 by P1 base 2 plus P2 log 1 by P2 base 2 bits per message. Okay, just we consider the entropy equation for two messages. Okay, and first message probability be P1 and the second message probability be 2. So H will be P1 log 1 by P1 base 2 plus P2 log 1 by P2 base 2 bits per message. Now please substitute 0.01 and P2 as 0.99. Accordingly, we can calculate the entropy for the three different cases. Now please substitute P1 and P2 with the values of H. What is P1? 0.01. P2 is 0.99. This is the first case. And this is the equation for entropy. This is the equation for entropy for two messages. For two messages. So then our entropy will be, upon substituting P1 and P2, H will be 0.01 log 1 by 0.01 base 2 plus 0.99 log 1 by 0.99 base 2. So this is 0.01 log 1 by 0.01 is nothing but 100. So 0.01 log 100 base 2 plus 0.99 log 1 by 0.99, that is 1. So I told you that log 100 base 2, we can write it as log 100 by log 2. And log 1.01 base 2. You can write it as log 1.01 by log 2. Okay. So I request one of the student please solve this value log 100 base 2. ఎంత వచ్చిందమ్మా చెక్ చేయండి. One of you please check that. Tell me the entropy value for the first case. So I request one of the student to please solve this problem. K0, K0. చెప్పండి ఆన్సర్ ఎంత వచ్చిందో చెప్పండి. ఎనీ వన్ ఆఫ్ యూ. I don't call the roll number because no one is responding actually. So log 100 base 2 ఎంత వచ్చిందమ్మా? Log 100 base 2.
6.64 ma'am.
6.64 multiplied by 0.01.
0.06 ma'am.
That is the first term. The second term log 1.01 by log 2 multiplied by 0.99.
.08 ma'am.
Sarpinda 0.08 bits per message. Okay. Okay. Similarly, please solve the second one. What is the second one? Second case enti? P1 is 0.4 and P2 is 0.6. P1 is 0.4 and P2 is 0.6. Please calculate the entropy for this case. H is P1 log 1 by P1 base 2 and P2 log 1 by P2 base 2. Please substitute P1 as 0.4 and P2 as 0.6. So it will be 0.4 log 1 by 0.4 base 2 plus 0.6 log 1 by 0.6 base 2. So 1 by 0.4 is 2.5 and similarly 1 by 0.6 is 1.66. So it will be log 2.5 base 2 and second term is log 1.66 base 2. Please solve this and tell me the answer for the first term and second term and total ఎంత వచ్చిందో చెక్ చేసి చెప్పండి.
.967 ma'am.
Okay. So finally you got the entropy as 0.97 bits per message. First case కి ఎంత వచ్చిందమ్మా? 0. See, please observe the first case. In the first case, you obtained almost all entropy as nearer to 0. This is 0.08. This is because here it consists of, this event consists of 2 messages. But the second message probability is like approximately equal to 1. And the first probability is almost all 0, that is 0.01. And second probability is 0.99. this is like we studied this condition as one of the property. A property enti? Which property it is? P2 is approximately equal to 1 and P1 is approximately equal to 0. Which property it is? సో మనకి అప్పుడే విచ్ ప్రాపర్టీ మా ఏ ప్రాపర్టీ ఫస్ట్ ప్రాపర్టీ చదువుకున్నారు కదా ఇఫ్ ఏ డేటా స్ట్రీమ్ కన్సిస్ట్ ఆఫ్ second property, if a data stream consists of multiple messages but only one message has maximum probability equal to 1 and other probabilities are 0, this is not completely 0 but approximately equal to 0, and first probability is P2 is not like approximately 1, not exactly 1 but approximately equal to 1, then our entropy will be approximately equal to 0. So మనకి ఎంత వచ్చింది approximately 0.08 bits per message. Okay, so this second case is like medium values 0.6 and 0.4. That's why you got entropy as 0.97 bits per message. Now what is the third case? Third case is P1 equal to P2 equal to 0.5. So at the equally likely condition, can you tell me how much value like how much entropy you will get based on the properties?
1 ma'am.
1. ఎందుకని maximum entropy for m equally likely messages occur at 1 by m and it is equal to log m base 2. m2 అన్నప్పుడు log 2 base 2, that's nothing but 1. So that occurs at p is equal to 1 by 2. So that's why here if you observe the third like case where p1 is equal to p2 is equal to 0.5, this is the equally likely condition. So h is equal to p1 log 1 by p1 base 2 plus p2 log 1 by p2 base 2. So just please substitute p1 as 0.5 and p2 is also 0.5. Here also the sum of the two message probabilities is 1. So 0.5 plus 0.5. So 0.5 log 2 base 2. So 1 by 0.5 is 2. And here also 1 by 0.5 is 2. So 0.5 log 2 base 2 plus 0.5 log 2 base 2. This is nothing but log 2 base 2. Okay, log 2 base 2 and log 2 base 2 is 1 because log 2 by log 2 both gets cancelled and you will get 1 bit per message. Now what is the conclusion? This problem is very important. What is the conclusion from the three cases? For equally, in this case, for equally likely condition, so if you observe this problem, here we mentioned three different cases, okay, of an event consisting of two messages. In the first case, P2 is approximately 1 and P1 is approximately 0. So that's why here entropy is almost all nearer to 0 వస్తుంది మీకు ఇక్కడ first case. In the second case, almost all average values of P1 and P2. So like 0.4 and other is 0.6. Okay. And in the third case, this second case is not exactly equally likely, but nearer to equally likely condition. This is approximately 0.5 and this is also approximately 0.5, but not exactly equally likely condition. So అందుకని nearer to 1 వస్తుంది. మీకు ఎంత వచ్చింది? 0.97 something you obtained. And in the third case, if you observe, here this is an equally likely condition. So here you will get maximum entropy for two equally likely messages is log 2 base 2, that is 1 bit per message. Okay, this is completely like even though two messages exist, only one message has maximum probability and other has like my minimum probability. And the second case is almost nearer to equally likely, and third, that's why the value should be nearer to. Okay, and in the third case, the two probabilities are almost like equal. So this is the equally likely condition. This is equally likely condition. So that's why we can say that the maximum entropy will occur here. Maximum entropy will occur under this case because P1 is P2 is half 1 by 2 kabatti. Okay. and that entropy is how much? It is 1. Okay, with this we can conclude our this second module. Okay. So in this module we can learn the concept, we completed the concept of average information, entropy and its properties.
మళ్ళీ ఫోన్ చేస్తానుండే వంశీ, మళ్ళీ చేస్తానండి.
So in this entropy we discussed the definition for entropy. Next what we did, we derived the expression for entropy and we discussed almost all 6 properties. Okay, so the like మీకు క్వశ్చన్ ఎలా వస్తుందంటే డిఫైన్ ఎంట్రోపీ అండ్ డిరైవ్ ఇట్స్ ఎక్స్ప్రెషన్ అండ్ ఎక్స్ప్లెయిన్ ద ప్రాపర్టీస్ ఆఫ్ ఎంట్రోపీ అంటారు. దెన్ యూ షుడ్ బి ఏబుల్ టు ఎక్స్ప్లెయిన్ ద 6 ప్రాపర్టీస్ అలాంగ్ విత్ దేర్ రెస్పెక్టివ్ ప్రూఫ్స్. Okay, and even you will get more like related problems or entropy in the next module, that is the third module. Here you will like we'll discuss the information rate. Here we will discuss the information rate and the related problems like related to both information rate as well as entropy. We'll solve all these in the next class, tomorrow class.